Hi there, and welcome back to Triplicate. And a little while ago, was it last summer, or the summer before even, I did a little video on our boat Bonny Mary, on the electrical systems of the boat. And just to recap, I'll try and remember to put a link in the description, but no guarantees. I'll try and recap on the relevant part. We have two big 100 amp hour batteries in parallel which run the electrical systems while the engine's not going, and the engine has a 70 amp alternator to charge them up, which charges them up pretty quick. But while we're moored up at the boat club, we don't want to be running the engine all the time just to charge the batteries up. So we have a little battery charger just to keep the batteries topped up while we're using the fridge and the lights and the water and whatever uses battery power, and we're not going anywhere. So this is the little charger we have been using ever since I rewired the boat. So it's been doing sterling service for the past 10 years ago. Sterling service? Oh dear. Oh dear, dear, dear. But last time we were in the boat, it found it wasn't charging the batteries at all and was making a rather pathetic little noise. So I thought we'll tear into it and see if we can fix it, I suppose, or if we can't fix it, why it's expired. I mean, it's only 6 amps and the batteries, there are two 100 amp hour batteries in parallel, so if they're reasonably down, it's probably trying very hard, so it's probably done well to have lasted that long. So we need, in the first instance, a replacement, and we're going to the boat this weekend, so we need it sharpish. So I had a hunt round at what I have for battery chargers, and I had a motorcycle. I have that Oxymizer Oxford unit, which claims to be 0.6 of an amp, so that I do not think will be up to the job. Fair enough, we can just leave it on all the time and I'm sure it would, you know, gradually bring the batteries up, but I'm not sure. I mean, it's designed to charge up a motorcycle battery that size, not too bigger than the camera will see deep cycle batteries. So I don't fancy the chances of that one doing the job without melting. The other candidate is this thing. I have to zoom the camera out, which as you can see has not been used in a long time because it is absolutely filthy. And again, if we look at this is just a good old transformer and rectifier type, which claims 4 amps RMS. Well, it's very simple design, so we're going to try this one, and we're not going to leave it running. We're just going to put it on the battery while we're on the boat, just in case it melts or explodes, because I can't say as I hugely trust it. So that's the short-term solution. Okay, so as for what to replace it with in the long term, well, there are a couple of 12 volt lead acid battery charger types on the market. This is the basic type, which is the same pretty much as the one I'm putting on, but I guess it's 8 amp instead of 4 amp, a little more heavy duty. But I don't really want to leave that on all the time, because it'll just pull power out of the mains and probably eventually overcharge the batteries, because it's just designed to stick on a flat battery and bring it up to where you can start your vehicle. And similarly, these guys, this sort of thing, these smart ones which do all sorts of fancy things, including pulse repair of batteries that have been left flat, but it's not doing what we want it to do. We want something to keep the battery topped up while we're not using the boat, and actually basically supply the average power we're using when we are on the boat and we're not using the engine. So I thought that I would design one and build one and bring you all along to see what I'm doing. So that will be the next video. I will start work on that. Meanwhile, our hacky old out of the arc type battery charger will have to do duty on the boat. Okay, before we tear into this, shall we just power it up and see how it's doing? Now, in the great tradition of my YouTube videos, it'll probably start working now. It usually does. Something fails and then when a minute I turn the camera on, it starts working again. So here we have my mains lead, health and safety approved, which I will connect to this because this was hardwired into a fuse box on the boat, and we'll power it up and see what happens. Okay, here we are connected up. You see the earth wires very professionally connected together, and it's off at the mains board over there. And here we have our digital meter. So we're gonna come on. Hopefully connect it up and power it up. You'll be really well to reach across here. And that is putting out 8 volts, no load. And the yellow light is on indicating high charge, but that's not going to charge anything at that. And it's making a bit of a sad noise as well, and if we turn it off, oh, the whine of death. You probably can't hear that on the camera, but it is. And as for if it's got a load on, okay, so here we have it all wired up. Remember, yellow is negative and yellow is positive. That won't cause any confusion. However, somewhere, oh yeah, here we have a light bulb, which is, I don't know what. Oh, it's a brake tail, so it should draw about 25 watts, 2 amps. And we've got the multimeter going, so let's turn her on again. Nope, not happy at that. 136 millivolts with a load on. Completely kills it. I'm back up to 8 volts on the no load, and it's very dim, showing yellow high charge. It's dead. I think we can safely conclude it is dead. So shall we tear into it? Yeah. Okay, so went off and did something else for a few hours, came back, and well, I'd left it turned on with no load, and suddenly the LED was lit up as charge and connected the load again, and put my hand over this or it'll just bleach the camera out. You can see it's now. You see that? Oh, it's not actually too bad, it's just LEDs that bleach the camera, and it's putting out 12.95 volts, so what was that? Might pull it apart anyway, just to see if there's a duff connection or something. Maybe there wasn't enough mains getting in or something. Dunno. Further investigation required. Okay, so here's weird. It is now 10 o'clock, 10:07. And it's turned off and there's no voltage coming out of it, so if we turn it on with no load it goes up to 9.5 volts this morning. It was 8 volts yesterday. And if we apply power, this is connecting the bulb across it, it goes back down to 160 millivolts and it's not having it. Okay, so it is now 10:32 and the voltage under no load has come up to 12.8, and if we connect the light bulb it lights up. So God knows what's going on there, and if it's disconnected it goes back to that 13 volts nearly, and if I turn it off it goes back to 100 millivolts, and that's just draining away. And if I turn it back on, it comes back up to 12 volts and works. So is it a thermal thing? Does something actually need to warm up before it works? I don't know. Let's tear into it and see what's happening. Alright, so I managed to locate the original email where I bought this thing. It cost me £75. Sterling Pro budget, 12 volt 6 amp battery charger. Try that. That is the best Google can come up with, and nothing that looks like mine, and I can't find the manual, so don't know. Doesn't exist. Can't find it on the Sterling website either. So doesn't exist. Never existed. I must have bought the only one they ever made. Okay, so we've got rid of the meter and the light bulb and all that stuff. We have here the plug, no longer plugged in, so I'm not gonna give myself a shock. I have a little tray for the screws, and I'm guessing it's a sort of moulded tube. I don't know. Anyway, I'm guessing the best shot is to take the screws out at the end. Let's do that. And here we go. Fourth screw out, and the cover comes away. And it looks conveniently like the switch and the mains wire are connected via those two little connectors, so we can get them away, and the top is held in by the end plates. That's quite a clever design. So I am going to whip these screws out the other end and get the top out of the way. And there it is, and I can already see some burnt looking resistor there. However, let's carry on. There's the top away. Let's get these connectors out. One and then that one. Should be things that side. Right, that gets the mains side away. The power wires and the LEDs. Well, the power wires are soldered down and the LEDs are soldered down, so we can't do something similar with this end, but we can, I believe, try that screwdriver. Get these two cable clamps out. Back in. There's one. There's two. They can come off and go in the little tray. Then the magnetic tray not helpful for them. These two screws can come out. And this end panel can come. When I go through there, that was the caster I put on the end. I guess it originally had crocodile clips on of some sort. And we're in. Okay, so we're in some of the way, and let's just have a look at a few of the bits we've got. Some transformery looking things. There and there, or in big inductors. And I'm getting its switch mode input and output. So there's a couple of chips, that one in a socket, so it was actually a bit worrying. That is a TL384. Shall we see if we can zoom the camera in? So that little guy is a TL384 2, which is a PWM controller, which I guess the output is PWM, and that controls it. That guy there is an MC14541, which is a programmable timer, so I guess it's doing some kind of, is it's charged up, if it is stopped, otherwise charge it for a time period, I don't know. There's certainly no micro in it. And get some line on that. These two little guys are opto-isolators, and they really wanted to isolate across them because there's a slot cut in the PCB there. So that's it. There's quite a lot of components, but not actually a lot to it. It's not hugely sophisticated, but what I also have noticed, if we look in here, I'll try and get it so you can see it. The PCB round here looks brown and burnt, and this resistor, if you look at it, the lacquer on it is all cracked and split, as though it's been getting hot. So what we might do is see if we can just quickly replace that and see if that makes it work again. But in the meantime, all the power transistors are clamped to the sides with little clamps and screws on the outside. So if we want to get at the PCB, because this is actually a U-shaped aluminium extrusion, I think they are. So let's get these transistors off ski and have a look at the underneath of the board. Just one clamp and one screw, and this, another power transistor, or transistors. Another clamp out. Just have a look at these, yeah, look at those, they are the same. It would make sense if you're designing it. So this is just the earth. Now we've got a knot on the other side. These have some kind of locked on. Yeah. What's going on here? It's another earth. it is earthed from two places. Right, I need a spanner, well actually a pair of pliers. So it's the glue on it. Okay, these nuts are glued on, so I'm not going to fight them, I am just going to... Serious vandalism. Whoops, missed. Cut through the wires. I'll teach you to glue the nuts on. I didn't want these earth connections to come off, however, that one's off. Right, same violence for the next one. Right, the second one came out dead easy, would you believe, but don't think I'm going to be reusing that screw. However, she should just slide out now. And we'll rid of the case. And, yep, so there's nothing and no traces on top, it's a single-sided board. Very nice. So where's this burnt looking section here? Which is here, yes, it's looking somewhat burnt on the back as well. Well, discoloured. Right, well what I reckon I'm going to do is I'm going to try and replace that resistor, maybe temporarily. You see that? Yeah. And see if it works. Just get these ends up straight. There we go. That should come out fairly easily. What have I got? Here we go. A pick. It'll pull on that. Whoops, I wonder if it stays in. So yeah, it's all a bit bodgy, but I'm not sure I would trust it anymore, even if I can repair it. But we'll try, we'll have a look. You can't see anything I'm doing, can you? And there we go, and there it is. Let's see if I can get the camera to focus on this. One somewhat burnt looking resistor. So we'll have to try and read the colour code and if all the burntness and see if we can find one. Right, don't touch anything because it all bounces if I touch the bench because we've zoomed in somewhat highly. But I think we've got problems here because I can't really read the colour code off that. You can see the other end. The lacquer off the outside on which the colour code is painted is all burnt off as a metal film resistor, and those are strips of metal film. I think the other side is possibly a bit better. We can turn it over. But I'm not sure I can read that. I will get my super duper magnifier out and have another go. But they also look, whatever colour they started out, they all look brown now because they're burnt. What I will also do is go to ohms, okay, and see what it measures, but I doubt it measures what it's supposed to measure, otherwise it would work. $75K. But it also seemed that when it, well, if this was the component that was causing the problem, when it warmed up it read differently. Okay, so you can see the little bits, it's the outer, I guess, lacquer, the paint on coming off this, so we really aren't going to find the value, but what we have done, what we can do, is measure it, and we get 75 or so K, which I think is unlikely, because assuming it's a half watt resistor, and power equals 0.5 equals V squared over, what am I doing, V squared over 75K, that would, I mean, V squared is a half of 75K, which is about 37K. So if we turn the old calculator on, put in 37,000, 192 volts would need to get that thing up to half a watt. And from the bit of the circuit it's on, I mean, it's here from, is that the mains end? I don't know. I do not know, maybe it is the mains end, and maybe it does do have 190 volts across it. However, we have here a hot air gun, and I'm going to try warming it up. Dropped it, so let's see what it reads now. 75K. It's actually not that hot. Let's get it properly hot. I mean, maybe it is the... Quickly, when it cools off again. No, 75 odd K. So, oh, and that is hot. Ouch. So, what do we conclude? We conclude that that resistor is somehow part of the control of the mains circuit. And it would make sense, this is the mains part, so to about here, yeah, there's a gap here. So this is all the mains part and this is all the low voltage part. And that resistor was actually functioning, but something else in here isn't. Something else has cooked. There are capacitors. What the power resistor there. Okay, so one last throw of the dice before we abandon this thing. I've soldered that resistor back in there, which seems it is part of the mains circuit and does have a high voltage across it and is not rated at a high enough power. Annoying meter. Anyway, so what else? So if we look this is the output of the switch, goes through that fuse and through this thing, which I think is a thermal trip. And if this thing's gone faulty, maybe, I don't know. So anyway, what we are going to do is connect it up, having it lying on the bench, probably upside down. Not at all scary. And we're going to turn it on and just see if power is getting through this here, what I'm assuming is a fuse. Okay, so this end of the that's the mains live, goes along here to the switch, to this pad here, which has this capacitor on it, and across, through the fuse to this thingy here, which goes to there. So we are going to check between the neutral, which is that pad, and that pad, and see if we're actually getting anything. And we want to be on volts AC, and we want to be keeping our fingers off of all this stuff, otherwise this might be the last, well, the last triplicate video might be the last triplicate video. So we are going to stick our meter, what did we say, between there, oh, not at all flaky, there and there. I reckon we should get mains. And we do. And just volts DC, check that I haven't actually fixed it. Somehow. Come on. Yeah, it's 7 volts there. So that wasn't the problem. Well, I am gonna call it a day at this, because this little battery charger what was the top, couldn't find any information on it on the internet. It's what, 11 years old. It was cheap, claimed to be a budget unit. The manufacturers claim no knowledge of it, at least on their website, and I like to leave it on when we're not on the boat, so unless I'm pretty sure it's going to be good, I don't really want it doing anything nasty. So I'm not going to proceed any further with trying to troubleshoot it. If it was, I don't know, a vintage synthesizer or something, we get into it and try and get it working again, but it just really isn't worth the time and the effort, and I've got other things I want to devote my time to. So an interesting little look at what's in it and what's gone wrong with it, but it's not going to be a repair it video, I'm afraid. So I might make more videos in future on what I do about the mains charger on the boat, but for now I'm going to call it a day on this video, so it's a goodbye from Triplicate. So, although I would like to build a battery charger, topper upper to our specification, this would take several videos over several months, and I need something on the boat now. And I did try that old battery charger and it's sort of kind of just about kept up. So I have purchased this from Paco, never heard of them, claiming 20 amps. It doesn't say on the front, but it says you can just connect it and leave it connected and it'll sort itself out, and it does 7 stages. And it does up to 200 amp hour batteries. Suits larger deep cycle battery, that's us. So I am going to do an unboxing, connecting up and seeing how it goes video down at the boat the next time we're down there. So that's just an update, because I know I did earlier on in the video say we were going to get on and make one. Well, in the first instance we're not, so that really is it for this video. So again, it's goodbye from Triplicate. Goodbye.